Okay, round two is a lot more pegs. The problem is almost entirely parsing, so it's a good showcase for Janet. So I'm going to start, I've already created this little dummy starting point, and I'm going to start just like I did before by defining a peg. And this is going to split the lines into a series of games. And a game is the string game followed by a space, and then a number, and then a colon space, and then we're going to have I'll call this the rounds. So we'll do these like multiple rounds of reading. So this is a single round of the game, and a game consists of multiple rounds. So rounds is semicolon and space separated round, and a round is a comma and space separated. I'll call it just a reading. And a reading is a number, and then a space, and then a color. And a color is just one or more word characters. But we have to capture that because that won't capture itself by default. And I don't want to capture it as a string. I want to turn it into a keyword. So I'll use this by passing a function as the second argument to replace. It's going to take all the captures from this peg as positional arguments. So if you just look at this is the function that, given a string, returns a keyword. So we're going to be doing that transformation. So this is maybe right. Let's try it. So I haven't put any like grouping or structure in here at all, but you can see if I wrote the matches correct. Great. Okay, so we captured all these values, and now we have to make sense of them. So first things first, let's take the ID and rounds of a game, and I'm using this short function syntax, but I'm just returning a struct. So I'll say the first argument is the ID, first thing we capture, and then everything else we capture are the rounds. So that's everything else. It's the $ampersand. And that helped a lot already. But the rounds themselves are not structured reasonably, so I think we want to group each of the readings within a round. And that looks pretty good. And I want to take these, actually, instead of grouping them, I'm going to take them and turn them into a struct. So this is a reverse of what I actually want, because this parsed the kind of the count first, but I want to turn them into a struct where the color is the key and the count is the number. So what I can do is say struct of reverse of all of the captures, but I then have to splice that back in because struct expects like just positional arguments like that. We can't pass it a list unless we use splice to pass all the elements of the list as positional arguments. This is like apply in JavaScript or splat in Python. So did I write that correctly? Let's see. Yeah, cool. So we've parsed the rounds into these structs. Okay, so now let's talk about the actual problem that we have is we want to determine which games would be possible if we only had 12 red, 13 green, and 14 blue. So this one is fine, but this one, we only have 12 red. We saw 20 red in this case, so this one would not be valid given the 12, 13, 14 restriction. So in order to do this, struct is actually not the best representation. So I'm going to write a helper function to turn this struct into a tuple. And I'll explain why I want to do that in a second, but this will be, I'm just going to call this my struct and shadow the function name. It's a list1, don't worry about it. And what I'm going to do is return a tuple. I'm going to look up in the struct. I'm going to look up red, and if that's not found, I'll say 0. And then I want to do this for blue and for green. I'll just test that, make sure I didn't screw it up. So that's good. And then that'll be red 10. Looks good. Okay. Did it. I called it RGB and then I wrote it RBG though, which is not great. Didn't have a test case for that. Like that. Yep. Okay. And the reason that I want to do that is because we can take advantage of a property of the map function. So map, as you probably know, you give it a function and a list, and it'll run the function over all the elements of the list. We could actually give it a multiple argument function, and then you can give it two lists, and it'll zip them together. So map, I almost always use seek instead of map when I'm mapping, and I almost only really use map when I want to zip. So this is a case where we have a bunch of readings, and we're going to zip them together by taking the max of the elements. So that isn't very interesting, but say that we saw like 10 red. So this sort of does this element-wise max operation and gives us like the most red, green, and blue that we've seen across all of the rounds. So if we do this for our test input, I'm just going to put this in a function up here so I can read this more easily. So given some input, we'll parse this, and then we'll say like game summary maybe. Summarize it. So this will take a game which has this ID key that we're not going to use and this rounds key. So rounds. And we'll say map RGB rounds to get the actual rounds, actually using map. And then splice that into this max operation. And then if I did that right, kind of a long shot, summarize ID 0 doesn't matter, rounds, something like red 10. So that looks right. And then if I add this one as like green 5, red 11. Cool. So that gives me the like, I don't know, max pairwise, element-wise max of all the color components. I don't really know how to say it in English. So let's do that. So we do this map, and let's say for each element in here, we'll say for game in peg match. Actually, I'm just gonna call this summarize rounds, and we'll pass in the rounds instead of passing in the game. This will make this slightly simpler, I think. Because we need the ID in order to calculate the final answer, because we're going to sum all of the IDs that match this property. So let's summarize rounds. And this is just for me to test it. This isn't the actual answer. Give that the test input. It did not work. I did not update this. Summarize rounds. Great. Okay, so that gave me the summary of all of the games. Great. And I'm going to just save that as summary. So we have a local variable. So I'm going to be using this loop DSL syntax a little bit here. So I have the summary, then I want to say when, and basically when, I want to say like when 1, 2, 3 is less than my 12, 13, 14. but I can't just call less than directly like this. I sort of want to zip the less than over the two lists, so I'll just use map again. So when map less than, when the summary is less than our 12, 13, 14, then take the ID. So that will give me all of the IDs matching this property. Oh, whoops, I didn't want to just map it. I wanted to actually map and then reduce it to say they're all true. So all is another function, and just like map, it's like zip, but then it reduces and makes sure that everything returns true. So 125. Um, and looks like, yep, that is correct for the test input. And it doesn't just want the IDs though, it wants yet another sum loop, and it says 8, which is correct. So that's the test input. Let's try the real input. Did not work because this is test input. Great. 2191, which is wrong. So that is because this should be less than or equal to 2528. Great. Uh, okay. Then part two of this is actually easier, I think, because you sort of solve part two in order to solve part one. So what you need to do is instead of doing this like less than operation, you just calculate this, what I called the summary here. And I didn't like do it this way because I knew that we're going to need it for part two. This just seemed like the natural way to do this. But it ended up working out nicely in practice. So we're just going to take the summary, get rid of that. And what it wants to do is sum up the product of all the reds, greens, and blues. So just like Janet has sum, Janet also has product. And we don't actually even need the ID anymore. And that's it, I think. Solve the test input, 2286. I'll solve the real input and get, yep. Okay, so that was it. So I actually like solved it this way initially before I knew it, and was kind of surprised that part two didn't really make the question any harder. That's the end of part of day two, but I want to talk a little bit about this Janet subtlety, which is why I made this RGB helper function. Because you might be tempted, and you might notice, you can actually map over, like, I'm going to say red 1 less than red 10. So that gives you true, and we can like green 20, green 30. It's like true, false. So this really looks like it works. And it looks like you don't actually need to do this conversion. I mean, uh, for one thing, it might not actually. So if we have red, green, and blue, that still gives me the same answers, because what this is really doing when we use map over a struct is it's saying, give me the values from this and the values from that, and compare that. Because when you iterate over uh, a struct or a table, you're actually iterating over the values. Uh, and when you iterate over a tuple like this, you're iterating over the values of the tuple. That should be values. So that's like the equivalent expression. Instead of mapping this, let's just take a look. So 130, 1020, these are the elements. So you could maybe pad this out so to make sure that you always had red, green, blue, uh, and make it zeros. And then you might think that would be sufficient, but even then it's still probably not, because you're relying on values. You're relying on the iteration order of the keys in the struct being stable. So if we have two structs with the same set of keys. And I think, just as Janet is currently implemented, this is actually true for structs, but it is very much not true for tables. Um, it just sort of happens to be true for structs because structs are the representation of structs with the same keys are literally identical. Uh, but a table, depending on how you constructed the table, its hash entries could be anything, and you could be iterating over its values in any order. So you really don't want to rely on this like kind of clever seeming at first like overloading of the values here. Um, that's why I turned them into tuples because that lets me use this nice uh, zip property of map and zip property of all as well, which, yeah. When I initially solved this, I didn't actually do this, and I wrote helpers for zipping and folding structs and tables, and it maybe will be useful in a future puzzle. I don't remember if I ever use those helpers ever again, but I think for this day, just turning it into a tuple is the simplest thing to do. And that's it.